You see some of that red under here? It's not very, it's kind of faint. If you look on that shark model up there, the shark head, see those ones that are all pooling, all those little ones that are going into a main line in the back of his head? This is what this is. What you need to do is take like a finger or a scraping tool or something and scrape all that stuff off, see that, all this business that's coming off, and then you can see it much more clearly. These are the efferent E exit. That's how I remember it. Because it goes. Here's your heart right here, and it's gone. See, you can see one of the arches going right there by the heart is where it's going out. I got something a little pointier to point out. See right there. It's coming out of this. So that's the one going in right there. It's going out. You got these arches, and they're going into the gills. Through the gills, getting oxygenated. This is oxygenated blood. It's pooling, coming out of all these. It's pooling into one main line. One, like, bunch of little lines in your house. You know, your drain, your sink, and all that kind of stuff. All goes into one big main drain line. This is his big main drain line. This is what's feeding all of the arteries in his body. If you pull this up, you can find, oh, there's one that goes to the spleen, right here. It's probably a splenic artery. Here's one that goes to the small intestine, right here. Here's going to be one that goes to the testicle. There'll be one that goes to here, but you just kind of lift this thing up.
Testicle?
This one, and there's another one on each. There's one on each side.
That one.
It's right here. Well, that's why he's still, especially on the smaller specimens, you can lift this thing up. And right under here, here's his clothes. See that little hole right there? Or what it kind of looks like a scar?
Yeah.
Right there? Yeah, right there. That's that, what the abdominal pore that you were supposed to learn for the viscera thing. That's his abdominal pore. Because back in the day, these lower organisms, their gametes were they were just expelled into the coelom. Okay? So the testicle and the ovary would have no attachment to the cloaca. It would just dispense into the gut. And then when the babies were ready to mate, they would just squeeze their stomach and just abdominal contractions and squeeze their gametes out through these abdominal pores. So it wouldn't be connected. And it's only once they get a little higher that you start having this common pathway where you connect, in this case, the testis with the kidney. This is all...
Which one is the kidney?
See all this crinkly line right here? This whole thing, part of it is going to be, and it's not, y'all haven't looked at it yet, I think it's maybe next week after next. But part of it is latex gland, part of it is archinastric duct, in this case since it's a boy. In a girl, part of this would be, there would be oviduct, and the ovary, her little ovaries would be up here, in the same place as the testis.
Oh, okay.
But once they started sharing an opening, and then once you start evolving further, like in mammals, mammalian males have a common opening for reproductive and excretory waste for urine, where female humans have two separate openings, where you've evolved enough to where it's completely diverged. Where this thing, not long before this thing evolved, they were just excreting them into the coelom. And even in the female, the ovary and the egg, the fallopian tube are not completely connected. There's still got a little space in there where your coelomic fluid can get in there, and there's pressure changes and all that kind of stuff. So even in in us that we're still highly advanced, we're still not complete. But most of the arteries and stuff, you can just kind of lift this, and this is that main aorta right here. You can
the red one?
Yeah, that red one. You can trace all of those off of that. And then these ones on the side, these lateral abdominal veins, these are like the big collecting tubes. So it's gone to the body, gone to all the muscles, organs, all the other business. This is pretty much how it's going to come back. These ones. You have intersegmental ones. These are like from the, bringing blood back from the muscle. Pulling back. All comes back. You have these sinuses, these huge blue sinuses under here. See underneath this right there? That's one of the sinuses I think that's the posterior cardinal sinus. And you go look on that model and you'll see these huge blue sacs. And that's where all the blood, it just kind of pools back in, because he's only got single circuit circulation, so the blood that's coming from his body goes into his heart, gets pumped through this big aorta right here, right there, out, through the gills, right here, gills, and here's the rakers, the hard bit, and the filaments are the soft, red, feathery bits back there. It goes through the gills, so you're taking this big blood through this big hose right here. It's pretty decently sized for this size, for this size animal. It has to go through that and then go through a little tiny straw, so you're like trying to blow, through those little coffee straws. through his gills, through the gill, through the gill, through the gill, through the gill. Then all that blood's got to come back and pool, and all these are afferent, the ones that are going into the gill. Afferent. Afferent going into the gill, and you have efferent coming out of it, they're exiting, so I think, and they're having to pull back in another big line, so you're having to go from a big line, little tiny line, to a big line. So you lose all your pressure. And so, it's, the pressure to his muscles is not that great, and so the return pressure is even worse. And so that's why you have these big sacs where the blood just kind of pools up, so you have a big supply. So if you just have it dripping in, you want a big bucket. So if you're going to take a big bucket out of it, it has time for it to, that little slow drip to replace it. So by the time you're ready to pump again, it has more blood. So. Whereas in us, we have double circuit because we want more blood pressure. So you have to, send blood to your body, comes back to your heart, gets transferred to your pulmonary circuit, goes to your lungs, get reoxygenated back to your heart, and then boom! And basically your heart is like a big book.